This is chemistry. I'll post them as separate videos. This is nitrogen, questions 1 to 8, 10, 12 to 15, 17 to 19, pages 37 to 42, required for the periodic, and this is the material. Okay, uh, I'll do the rest of the course revisions in different videos. Okay, how is nitrogen extracted industrially? Nitrogen, you guys know, it's from the fraction distillate. It's from the distillation of liquefied air. Okay, you get this like this. Okay, how is nitrogen extracted industrially? It's from the fraction distillation of liquefied air. And okay, you should know that air, you compress it until it liquefies. When it liquefies, it releases water and CO2, and you're left with nitrogen and oxygen. Okay, and nitrogen and oxygen have similar boiling points, so that's why you use fractional distillation. And since nitrogen has a lower boiling point, it's gonna leave the distillation first. Okay, Okay, does the process involve primarily physical or chemical changes? Of course, it's physical changes because you're melting, boiling, whatever. Is the nitrogen collected pure? No, it will have. Okay, you should know this. These are just things you memorize. Okay. Uh, list 3 uses of nitrogen. What are 3 uses of nitrogen? Fertilizers, whatever. Obviously ammonia by the Haber process, which we have another. Oh no, this is the section of ammonia. Yeah, this is the nitrogen section. Ammonia for Haber process, fertilizers and coolants. Just say coolants. Yeah. Okay. Ammonia, uh, fertilizers and coolant. Yeah, just say coolant. Or you know what? Just say making nitric acid. Nitric acid is easy. So you need 3 ammonia by the Haber process, fertilizers, and nitric acid. Just take those 3. Give the most important use of ammonia. Ammonia, you use it for the manufacture of fertilizers. Memorize it like this. Okay, that's why we need. Ammonia is used to make ammonium nitrate by reacting ammonia with nitric acid. Write a chemical equation for the reaction between ammonia and nitric acid. Obviously, just add them together. NH4 plus NHNO3 to get NH4 NO3. Yeah, so that's it. Like NH3 ammonia plus ammonium nitrate. Nitric acid. Nitric acid is HNO3 for those who don't know, but for those who know, it's HNO3. So you're gonna get NH4 NO3. Then for part C, they said describe a test that you could perform to show that ammonium nitrate contains ammonium ions. Remember, to test for ammonium ions, you add uh, a base, and you would get ammonium gas. I'm sorry, ammonia gas. Sorry, ammonia gas, and I think you get water. I'm not sure. I think it was it what? Yeah, it's water. Yeah, and what observation would you get when you get ammonia gas, guys? You get you change litmus paper from red to blue, and it produces a pungent smell, right? Okay. Uh, Question 4. Ammonia is produced by the Haber process according to the equation. The graph below shows how the percentage of ammonia changes with temperature in the mixture at equilibrium. It's an equilibrium reaction. So remember that you have Le Chatelier's laws, they all apply here. What is meant by the term dynamic equilibrium? This comes almost every exam, guys. Two processes containing two dynamic processes happening at the same time. So two processes continuing to take place in opposite direction at equal rates, and the concentration remains constant. The rate is equal. How does the percentage of ammonia change with temperature? أكيد if you like look at this يا أخي, as temperature increases ammonia decreases, as temperature increases ammonia decreases. أيوة. On the graph below, sketch the graph that shows what happens to the percentage of ammonia as the pressure changes. What do they mean? يعني? Oh, they want as pressure increases. Oh, okay. Obviously, if you increase the pressure, the system would want to decrease. I mean, this isn't coming for our exam, but it's required in the question, so you should know. If you increase the pressure, then the system will want to decrease the pressure, so it will go to less gaseous moles, right? Where is the less gaseous moles? It's to the right. So if you increase the pressure, it's going to move to the right. So as you increase pressure, the ammonia, you're going to label your axes. If this comes written, if you increase pressure, the percentage of ammonia will increase like this. Okay. Oh, and it can't. Yeah, it can't start at 0 because you can never have 0%. Okay, it will be like this. Okay, start sync. Okay, explain why the graph in part C has the. Oh, can just sketch it here. Okay, I don't know why. Okay, explain why the graph in part C has a shape described. We just explained it, guys. We said as you increase pressure, it favors the side with less gaseous modes. Whatever. Answer the following questions regarding. Okay, during the Haber process, only a small percentage of hydrogen and nitrogen gases convert to ammonia. How are the unreacted gases separated from ammonia? The unreacted gases are separated by cooling the mixture. Okay, yeah, yeah. Let me open the notes. So basically, here they're saying, some ammonia is actually formed, and the rest is hydrogen and nitrogen. How are they separated? Over here, they drew it for us in the notes. Basically, nitrogen and hydrogen are pumped into the compressor. They're compressed. They go down here. They react. They react here because this is where the catalyst is. Remember that it's iron catalyst. Uh, it goes through here. This is where it actually reacts, and once it reacts, it forms ammonia and some unreacted gases. Where do they become separated? They become separated in the cooler. Basically, here the ammonia liquefies, and the rest, nitrogen and hydrogen, remain as gases, and they go back up, and the process repeats. So, how are they separated? Through cooling. What happens to the remaining gases? They are recycled to react again. So that's part B as well. So during the Haber process, only a small percentage is converted. How are the unreacted gases separated from ammonia? You say they are separated by cooling. Okay. And then what happens to the unreacted gases? They are recycled. Okay. Once they are recycled, it increases to 85. I'm pretty sure that's wrong. I remember seeing 98%. It's, yeah. It can be increased to about 98%. The value in the course revision document is wrong. Haber process uses a low temperature, yet the percentage yield is 15%. Explain the high percentage yield. Okay, basically, they're asking, since it's using a low temperature, but the yield is still high, it's 15%. Can you explain that and how? So look, here it's an exothermic reaction because, okay, just it's an exothermic reaction because bonds are being formed. When bonds are being formed, it releases. It's exothermic. Okay, you should know it's exothermic. What happens if you lower the temperature in an exothermic reaction? If you lower the temperature, the system is gonna favor the increase in temperature. It's gonna favor the exothermic side, and the exothermic side is the forward. So it's gonna favor the forward. Okay. So over here, basically, I'll just show you the solution. Since it's exothermic, if the temperature is lowered, the system shifts to the right. Whatever. Yeah, and these equilibrium questions, I doubt she's gonna bring them for the periodic, but for the final, definitely you need to know them. What is the effect of what's the effect on the rate of reaction and the equilibrium position when the temperature is increased in the Haber process? Effect on the rate of the reaction. Of course, if you increase the temperature, then the rate of reaction increases. But if you increase the temperature, it's going to favor the endothermic side, and then the equilibrium will shift to the left. That is, by the way, why you can't really. That's why you can only increase the temperature until a certain extent. What is the effect on the equilibrium position when the pressure is increased in the Haber process? If you increase pressure, we said it in a previous question, if you increase the pressure, it's going to favor less gaseous moles, hence it's going to favor the product. Okay, so let's see here. Position of equilibrium shifts to the right because it shifts to less gaseous moles. Okay, guys, if you're not sure about anything, you can just talk to a chemistry teacher. It's fine. Any chem teacher or anybody on the group, they can help you out, especially the WhatsApp group. Part F, one of the scientists working in a factory to make ammonia suggested altering the pressure to 1000 atm and the temperature to 250. Explain using your knowledge of equilibrium if the scientist accepted or not. No, because if the so obviously increasing the pressure will be good, but it's too expensive. That's in the book. They said no شو اسمه if you increase the pressure too much, it's gonna be too expensive to build it. Okay, so look, when the pressure is increased, according to Le Chatelier, the equilibrium will shift to the right, forming products. Okay, Ali. But then they say, also they said increasing pressure increases rate, whatever. It's a good idea, but it's expensive. Okay, but obviously you have to explain all this. I doubt they're gonna get this because it needs equilibrium. We don't have equilibrium. Where's the material? 1 to 8, 10. These are still required. I don't know why. Okay, the diagram shows some reactions of substance X. Substance X, when heated with an ammonium compound, gets you ammonia. Substance X heated with an acid gets you a salt. So, Obviously, what plus acid gets you salt? Obviously, it's a base, and when it's added to an ammonium salt, it gets you ammonia. Obviously, it's a base. Which type of substance is X? It's obviously a base. So 6 should be base, a base. Okay, how could we obtain ammonia from ammonium sulfate? Ammonium sulfate. Yeah, so I don't know where I stopped because I had someone came. I had to stop the video, but I think I did part A. I said base. How could we obtain ammonia from ammonium sulfate? You guys know the reaction. It's base plus ammonia. Sorry, base plus ammonium salt to produce ammonia plus water plus salt. This was one of our famous reactions over. It's somewhere here. Wait, 15. Yeah, ammonium salt plus base gets you salt plus ammonia plus water. For example, ammonium chloride plus sodium hydroxide gets you NaCl, ammonia, and water. So here we would say heat it with an alkali. Alkali, for those who don't know, is base. But for those who know, uh, it's an alkali. Okay. Uh, Complete the following equation. Something plus ammonium chloride gets you NaCl, ammonia, and water. You should know that what we add to get the salt, ammonia gas, and water, always base. We need, in our base, we need Na, right? So what's the base going to be? NaOH. It's always something OH. Since we need Na, we have to put NaOH. Very nice, very easy, very chill. Given the following N compounds, use A, B, C, D, or E to identify the correct structure. You can also use each structure once, more than once, or not at all. Which structure represents an acidic oxide? When is it an acidic oxide? When it's a non-metal oxide, right? Obviously not this. Obviously not this. Obviously not this. Obviously not this. E. You guys remember? NO2. It's where was it? I saw it. I think it was this one. Yeah. These are all the oxides you must memorize. And these are the famous ones. Always the O2s are. I don't have NO2 written here. Okay, always the O2s are acidic. Okay, you should know this. Oh, an ionic structure. You guys know ionic structure is metal and non-metal. Let's see. Ammonia, obviously not. Potassium nitrate, obviously not. Nitrogen fluoride, no. N2, no. Wait, what was the answer here? B? Potassium nitrate. Okay. Because, yeah, okay. When they say ionic structure, oh no, they don't mean it like that. They mean something that has ions in it. Let me show you. NH3 doesn't have ions. If you dissociate it, it's not ionic, right? Even though if you dissociate in water, you will get OH minus because it's a base, but it's a partial dissociation. We don't want that. KNO3 is potassium nitrate. If you dissociate it, you're gonna get what? K plus and NO3 minus. NF is just a compound. N2 is just it's a compound. NO2 is just a gas, right? NH3, no. Potassium nitrate will get you K plus and NO3 minus. Okay, these are stupid questions. Just memorize them in case they come. A gas which turns damp red litmus paper blue. You guys know, everybody knows this is ammonia. So, of course, it will be A. A compound which is formed under conditions of high temperature and pressure in car engines. This is very important. Uh, Car engines, it's nitrogen dioxide. So, it came in the periodic, and many people didn't put NO2. They just put it. I remember the answers were CO and NO because they were in the quiz. It was in one of the quizzes. I think it was. Yeah. So basically uh, here for the cards, it came. It was carbon monoxide, nitrogen monoxide, as well as NO2, nitrogen dioxide. Okay, but it was wrong at the exam because she counted NO2 as wrong for some reason. But then she cancelled the question in the periodic. Anyway, okay, part E is a molecule containing halogen atoms. Obviously, it's going to be C because F is a halogen. Yeah. And then a salt, Again, we said ionic. B, so salt. It's a salt since it's ionic compound. B. Okay, question 8. Fertilizers usually contain compounds of nitrogen, phosphorus, and potassium. Nitrogen for green foliage, potassium for healthy growth, and phosphorus for strong roots. Ammonium phosphate, NH4, 3PO4 is the fertilizer. Which two elements in ammonium phosphate are important for plant growth? It should be nitrogen and phosphorus. I think A. Nitrogen and phosphorus, yes. Why do farmers use fertilizers? Obviously, for plant growth, for faster crop growth and better crop yield. If anybody's doing IG Chem, you need to know this, by the way. Many fertilizers contain ammonium sulfate. Ammonium sulfate is made by reacting aqueous ammonia with sulfuric acid. What is this type of reaction? Base with acid. What do we call it? We call it neutralization reaction. Okay. D. Aqueous ammonia reacts with nitric acid, so ammonia and with nitric acid to make another compound often found in fertilizers. Give the name of the compound produced. The structure of ammonium sulfate is shown. Okay, forget about this. Okay, the name of the compound produced when you react ammonia with nitric acid, HNO3. What do you get? You get base. You have base acid. You get salt and water, right? What's the salt? Box up the middle. You're gonna get HH. We don't want that, right? You need to know when you react ammonia with an acid, it doesn't react as NH3. It reacts as NH4 plus OH minus. That's how NH3 reacts. Okay, so it's NH4 plus OH minus plus HNO3. And basically you're gonna get, now if you box it up, let's ignore the OH. If you box it up, H4 with H doesn't do anything. OH with H doesn't do anything, gives me water. But NH4 and NO3 gets me what? Ammonium nitrate. And obviously you have the H and OH, which is water. Okay, know this. I'll give you a rule. Okay, if you have ammonia plus any acid, you get ammonium salt plus water. Okay, memorize this. So in this case, you get ammonium salt. So change NH3 to NH4, and obviously we're not going to add the H from the acid. We're not going to add the H. Obviously, we're going to take the NO3 to NH4 NO3, which is ammonium nitrate. Give the simplest ratio of ammonium and sulfate ions in ammonium sulfate. Do you mean like 1 to 2? Wait. Is it 1 to 2? 2 to 1. Okay. Yeah, these we said ammonium nitrate, NH4NO3. They said formula or name? Name, yeah, ammonium nitrate. You could have just, you don't have to give the formula. You could have just said, oh, ammonia with nitric acid and ammonium nitrate. Okay, here, for the simplest ratio, this is supposed to be E and this is supposed to be F. The simplest ratio of ammonium and sulfate ions. How many ammonium do we have? We have 2 and 1 sulfate. So it's going to be 2 to 1. Ammonium sulfate. Okay, ammonium salts react with bases, alkalis. For example, ammonium sulfate plus sodium hydroxide gets sodium sulfate plus ammonia plus water. Let me go down. Deduce why adding staked line to fields which have fertilizer spread on them may result in loss of nitrogen. I don't know why. Why? Slaked lime is calcium hydroxide with water can form an alkaline solution which can react with ammonium salts. Okay. Okay, yeah. Lime is calcium hydroxide. Okay, you should know this because calcium, when you dissolve this in water, we get what we call lime water, and it turns that's the test for CO2. Anyway, so when we see lime, it's calcium hydroxide, and basically, if you add it in fields, it's going to react with water, which is going to form a base, and instead of the ammonium sulfate reacting with the plants and being absorbed, it's instead going to react with this base because calcium hydroxide is a base. Okay, so basically, what they said here, it's calcium hydroxide, which might form a basic solution, and it would react with ammonium salt instead of the plants. These questions, يعني كلهم almost, يعني I doubt half of these will come. I doubt half of these will come. 10, 12 to 15, and go faster. Give 3 simple tests by which you can identify ammonia gas or a solution. 3 simple tests? Ammonia gas, I guess it would be litmus paper, maybe. Well, let me see. Smell, litmus paper, formation of white fumes in the presence of HCl. Okay. So apparently, if you put HCl, it would react with the ammonia to form ammonium chloride, which is white fumes. Okay. And then she said 12, I think. 12 to 15. Okay. List three uses of ammonia. We said fertilizers. I don't know. Let's see. Ammonia is used for fertilizers. Such as ammonia. There's three uses? There's only one, no? Ammonia is used in the production of fertilizers such as ammonium sulfate and ammonium nitrate. Okay. Uh, they listed. These are the other three. Ammonia is involved in the production of many polymers. Ammonium is used in laundry as a decreasing agent. Okay. The only one they're gonna ask you tomorrow is probably gonna be this one. What do they say? Write an equation to represent the reaction of ammonia gas with concentrated sulfuric acid, in which only one solid produced is obtained. Write an equation to represent the reaction of ammonia with sulfuric acid, in which only one solid is obtained. Okay, I guess it's pretty easy. Ammonia gas NH3 plus sulfuric acid H2SO4. You're gonna get ammonium salt, so NH4 SO4 plus water H2O. Is this what they want? I have to balance, yeah. Put two NH3. Because why did I put NH4 2SO4? Because you guys know it's always gonna be ammonia plus acid will get you ammonium salt plus water. SO4 is SO4 2 minus and NH4 is NH4 plus. So if you crisscross, you can get NH4 2 SO4, huh? And then once you balance it, since you have two here, you have to put two here. That's pretty much it. Okay, guys, since it's a solid, we make it solid. They said in the question they said it's producing a solid. Yani they want to be solid. Okay, this is here aqueous. Oh no, they said gas. They said ammonia gas. The gas H2SO4 is aqueous. If they don't mention its state, it's aqueous, and if it's water, it's just liquid. Write an equation to present the reaction of solid ammonium sulfate, so NH4SO4, with potassium hydroxide solution, so plus NaOH. This is ammonium salt plus base. What do you get? Ammonium salt plus base always gets you salt. What salt is going to get? Box up the middle, SO4 and Na. So it's going to be Na2SO4. Why? Because it's Na plus, SO4 2 minus, crisscross, you get Na2SO4. You always get salt, water, base. So H2O liquid. This is here aqueous. This is liquid plus ammonia gas. This is here solid. This is potassium aqueous because he said solution, huh? So remember, ammonium salt plus where is it؟ ما بديش ارجع اشوف بس خلاص wait اشوف 15. Ammonium salt plus base gets you salt plus ammonia plus water. Okay. They said 12 to 15. List three uses of nitric acid. These they don't come. Nitric acid is used to prepare fertilizers, explosives, and stuff, dye stuff. You should know fertilizers and explosive. Nitrogen is used for fertilizers and explosive. Okay. Like in Beirut, you guys know the explosion that happened in August 4, 2020. It's just more. What happened was basically there was a lot of ammonium nitrate, NH4NO3, and basically like they got lit up and they're very explosive. It went like خلاص, it just exploded and like the whole thing exploded. What is an NPK fertilizer? Why do plants need NPK? NPK basically nitrogen, phosphorus, potassium. Okay, NPK is one that contains nitrogen, phosphorus, potassium. Plants need fertilizers. Why do they need them? Obviously to grow faster. This one advantage and disadvantage of using fertilizers. One advantage is the plants grow faster, obviously, and disadvantage, it may cause eutrophication. This one they probably I doubt they'll ask it in your written part. But just if you see eutrophication, it's always a disadvantage. Basically, where's in lakes, nitrate ions flow. Like there's too much ions, so the plants they're gonna grow so fast because there's so much ions and nitrogen, and so they're gonna make so much protein that grows so fast. But since they grow so fast, they're actually gonna block the sunlight. It's like imagine there's a lake over here, okay, and there's like plants here, okay, and since there's so much nitrate ions flowing into and fertilizers flowing in, the plants are gonna grow and they're gonna cover the whole bed of the lake, and that means no sunlight is gonna flow in, and that means the plants that are down here are gonna die. Since they're gonna die, the decomposers will decompose it, and basically they're gonna take up all the oxygen, so the fish is gonna die. In short words, it's a bad thing. Okay, eutrophication is bad. Okay. How do you test for ammonium ions? Write the net ionic equation for the reaction expected to take place. To test for ammonium ions, you always heat it with a base, right? So ammonium ions, NH4 plus OH minus to produce NH3 and water. I think I just need to make sure of this. Aqueous. Okay. Add warm. Okay, base. This is the equation. You always add a warm base and heat. The reaction produces the pungent smelling gas ammonia. Ammonia can be further tested with litmus paper. 15. Ammonia. Oh, this comes every single exam. Ammonia energy is produced industrially from nitrogen gas and hydrogen gas by a process called the Haber process. Give the chemical equation for the synthesis. Okay, they always write the first part for you, and enter you're supposed to come. Oh no, actually they don't. Enter you're supposed to write it. Chemical equation for the synthesis of ammonia and the Haber process. Okay, N2 plus H2 produce NH3. We have to balance this guy. So we multiply by 3 here, multiply by 2 here, and since you have a 2 here, خلاص that's it. So it's going to be N2 gas plus 3H2 gas to produce double arrow. It must be a double arrow, okay? Because it's falls under equilibrium. 2NH3 gas. They don't want state symbols? Okay, عادي. Okay. What are the conditions of pressure and temperature needed for the optimum yield of ammonia in this process? You should know the temperature is equal to 450 degrees Celsius, pressure is equal to 200 atm. How I like to memorize it is nitrogen needs so much pressure to be collected, so that's why it's the one with higher pressure, 200 atm. In other words, 20,000 kPa. Okay, sometimes they ask it in kilopascal. The contact process of sulfur is different. We'll do it later. Different course revision video. Okay. Give the name of the catalyst used. For the Haber process, it's iron. Okay, fine iron pieces. Powdered iron with aluminum oxide. Okay, just no iron. If you just put iron, really, you just get it correct. Okay, what else? We have 17 to 19, and that's it. Okay, 17. And how long is it? Okay, we can bring it under 35 minutes. When petrol burns in a car engine, pollutant gases are produced. Name 2 gas pollutants that are released by a combustion engine and are converted into less harmful products and catalytic converters installed in a car exhaust. Catalytic converters convert CO and NO, okay, to make them less harmful, okay, as well as NO2 also. Any nitrogen oxide, by the way, is correct. Carbon monoxide and nitrogen monoxide. If they put NO2, pick it because it was correct in a previous question. It was correct in the quiz also. So know this, please know it. Please know it. It came in the last periodic, and I think she will give it this question, this periodic as well. Okay. Question 18. Classify the following salts as soluble or insoluble. Okay. NaNO3, obviously, since it has one of the big 5, it's soluble. CaNO3, since it has NO3, it's soluble. AgNO3, are they all soluble? Yeah, all of them are soluble. That's what I'm saying. It's also soluble. Because they all have nitrate. That's what I'm saying. NO3 is part of the big 5. Hatta the Na is also part of the big 5. Okay. Write equations to present the thermal decomposition of any NO3. And what is thermal decomposition? Nah, bro, what is thermal decomposition? We did not take this. And I know for a fact we did not take this. We are. So basically, for part B, it's not required. You don't need this. In case they do ask it, thermal decomposition basically is when you heat it up and it starts to decompose, but it always releases O2. Okay, so here, just NaNO3. The way you'd write it, just put NaNO3, put an arrow, put O2, and then take O2. Yeah, honestly, I'm not gonna explain something I don't know, but let me skip this. Don't take this. Skip it. You are given a sample of white powder told it's potassium nitrate. How can you test if it's potassium nitrate? Potassium is K plus. Flame test. And what would the flame test of K plus give you? It would give you a lilac violet flame, right? Nitrate ions. How do you test for nitrate ions? You add a base and aluminium, right? And heat or warm gently to get uh, NH3. So let me just check the solution key. Okay, prepare called solution S. Potassium ions can be tested by the flame test. Dip a platinum wire into solution S and place it into a blue flame. The color will turn lilac. Nitrate ions are tested by warming NaOH with aluminum powder as a catalyst. Ammonia gas is produced, which has a pungent smell and turns wet redless paper blue. I feel like they'll get you something like this, they'd ask you, how would you test for something? Which of the following fertilizers have the highest percentage of mass by sulfur? By mass of sulfur. I guess it's just gonna be this one because it has 3s. Yeah, exactly. It's C because it has 3 s's. Okay, that's it for sulfur. Thank you so much for watching and good luck.